This question is about a geometric sequence, and we're given the first two elements, 2.1 and 2.226. And first we're asked to find R, that is to say, the common ratio between all the elements. And we know that R is simply one element divided by the previous one. So R equals U2 divided U1. This would have been true for any consecutive elements, but these are the ones we have. So 2.226 divided 2.1 equals, asking the calculator, 1.06, and that's an exact value, so we just answer like that. Then we're asked to find the 10th element in this sequence. And we know that since the geometric sequence is constructed by taking the first element and then multiplying by the common ratio time after time, so the nth element, un, will equal u1 times r to the power of n minus 1. So in this case, u10 will equal 2.1 times 1.06 to the power of 9, and this is, if we ask the calculator, 3.54790. It goes on, and we approximate it to three significant figures according to IB standards, so it's 3.55. The last part of it, we're asked to find an n such that Sn, that is to say the sum of the n first term in the sequence, should be larger than 5,543. So first we need to figure out how can we know Sn, and we look in our formula booklet and see that Sn equals u1 times r to the power of n minus 1 divided r minus 1. So in our particular case we have 2.1 times 1.06 power to the power of n minus 1 divided 0.06. And this we can plug into our calculators. We can run it as a function. I mean, we could ask the equation solver to solve this to equal 5,543 and then see what surpasses that. Or we can graph it and see where it's cutting the line of y equals 5,543. However, it should also be possible to solve it analytically. So for this question, it would have been enough to use this and then use GDC, graphic calculator, which would give us that the equality would be n holds for, or n should be larger than 87.0316 and so on. So the smallest value of n, we're after the least value of n, which makes this true, so n should be 88. But let's look at the equation and see if we can solve it, because we are after all doing logs and exponents as well. So we have, and I'm going to solve it as an equation and then we'll sort out the inequality afterwards. We have 2.1 times 1.06 to the power of n minus 1 divided 0.06 equals 5543. And we solve it in the usual way, so to speak. So we have 1.06 to the power of n minus 1 equals 0.06 times 5543, everything divided 2.1. I'm not going to put this into the calculator, but we end up with 1.06 to the power of n equaling, well, this one plus 1 times 5543 divided 2.1 plus 1. How could we solve this? Well, again, we can do it graphically, but we can also take the natural log of this, natural log of that. So it's gonna end up with, I need a new paper, sorry for this. Right, I hope this is somewhat clear. If I take the log of both sides, I get, I could use any base, but I'm going to use the natural logarithm this time. So ln of 1.06 to the power of n equals ln of this whole thing. 0.06 times 5543 divided 2.1, everything plus 1, and so. Why did that help? Well, we know what happens when you take the log of something raised to the power. So this is the same as n times ln 1.06 equaling this whole thing. I'm just gonna copy that down like that, because this means that n equals the log of 0.06 times blah 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 divided the log of the logarithm of 1.06, and everything here are known numbers, so this we can put into a calculator and get n, and in this case n would equal, since we solved it as an equality, 87.0316 and so on. And we know that we want the smallest integer larger than this, so really the n that we looked for should be 88. And I do apologize for the bad rigor of writing n equals here and then giving it another name. You know what I mean. This kind of equation solving should be within our reach. There are not so many questions on it, but it's something that, I mean, this is basically a change of base using logarithms, and you should practice it.